Alright, in this video we want to talk about continuity, how to test for continuity of a particular function. Most especially we'll be dealing with a piecewise function. Alright, so I'm going to give the 3 steps to use when it comes to continuity test. Alright, so when it comes to 3-step continuity, the first step that we must do is f of a must be divine. Number 2 is that limit x approach a from the left hand side of a must be equal to limit x approach a from the right hand side of a. Then the last one is limit s approach a of f of x must be equal to f of a. So this is the 3-step continuity test that we are going to use to solve our question. Alright, for number 1 we are going to be doing our example 1. Example 1, let's look at this example. We have f of x, a piecewise function, f of x equal to square root of x plus 2, x less than 2, then we have s squared minus 2, 2 less than s less than 3, then we are going to have 2x plus 5, x greater than 3. So we want to find the continuity of this function at x equal to 3. We want to know if this function, this piecewise function here, is actually continuous at x equals to 2. Now solution, this is how we are going to go about the solving. Now remember, f of a must be divine. Our a is 2, so our a is 2. F of a must be divine. That means f of 2 must give us a value. Now let's come back to our piecewise function. The one that has to do with 2 is this one and also this one, because they are the one that have to do with 2. But we are going to pick one of them actually. Now to do that, we are going to check. This one is saying that x less than 2. Okay, this one is saying 2 less than or equal to x. We cannot go for the one that is saying x less than 2. We are going to go for the one of 2 less than or equal to So that means we are picking this function. So that will be x squared minus 2. So f of 2 will be, anywhere we see x, we can replace it with what? With 2. So that will be 2 raised to the power 2 minus 2, and that will give us 4 minus 2. That will give us 2. Alright, we've find the f of a. That is the first condition. Now the second condition now is that limit x approach a from the left side of f of a must be equal to limit x approach a from the right side f of a. Now for us to do that, this is how we are going to go about it. Remember that our a is equal to 2. So the limit x approach 2 from the left hand side of our function. Now let's go and check our function again. Which one has to do with the left hand side? If you check the ones that have to do with the 2, this one and this second one, you will notice that this one here is talking about x less than 2. That is x less than 2. And what is here is also talking about x less than 2. So we are going to pick this, and that will be square root of x plus 2. All we have to do is to what? Use direct substitution, insert 2, that will be square root of 2 plus 2, and that will give us square root of 4, which is give us 2. Alright, now let's do well to find the limit from the right hand side. X approach 2 plus from the right hand side. Now if you check the right hand side now, you will see that this is talking about 2 less than or equal to x less than 3. So we are going to be using this for our second condition. So that is going to give us x squared minus 2, and that is going to be 2 raised to power 2 minus 2, and that will still give us 4 minus 2, which is equal to 2. So with that now, you will notice that the limit from the left hand side and the right hand side is equal to 2. That is the second condition. Now, what is now the last condition talking about? The last condition is saying that limit f of x as s approach a must be equal to f of a. Now, let me explain what this one here is talking about. In limit, whenever the limit x approach a from the left hand side of f of a is equal to limit x approach a from the right hand side of f of a, once they are equal like that, then the limit x approach a of f of x is also going to be equal to the value. That is, if this one here is 2 and this one here is 2, definitely this one here also is equal to 2. Another way that we can use to write this is limit s approach a from the left hand side of f of x equal to limit x approach a from the right hand side f of x equal to limit f of x approach a. Now take note, let's assume that this one here is equal to 1 and this one here is equal to 2. Definitely this is not correct anymore. So for this to be correct, this left hand side must be equal to what? The right hand side. Please take note of that. Alright, so going further, we only want to check for this third one, limit f of x as s approach a. We know that the answer to that now is 2 because the left hand side and the right hand side is equal. Now f of a, we've solved f of a to be this. Remember that our f of a is equal to 2. Now since limit x approach a, f of x is equal to f of a, which is equal to 2, then the condition is also satisfied. Then the third condition is also satisfied. Now if the third condition is also satisfied, it means that the function, we can now say the function, the piecewise function f of s is continuous at x equal to 2, and that is how to go about the solving. I will do well to ask you to solve at x equal to 3. At x equal to 3, I want you to give me the answer in the comment section. Alright, if you have not subscribed to this channel, please do well to subscribe and also click on the bell button. More videos on this is coming up. I'm going to be doing one particular example that has to do with this. Let me just write it so that you can watch it out. We have f of x equal to the piecewise function sine x ms plus b. Then this one is x less than pi, and this one is s greater than pi. So this will be on my next video. Please do well to watch it out. Thank you.